Hello, this video is about grid converter open loop voltage tuning. Here is our hill system. We have a DC source, DC breaker, drive itself. Then we have a LCL filter, MCB breaker, net breaker, and between here we have the D7 measurements. And finally, we have a constant power load that we can adjust here, Pref and Qref. In practice, a system can be something like this. Batteries are providing the DC link power. We have a drive, LCL filter, MCB, and after the MCB, we have a D7 measurements on the grid side that we are supplying in island or microgrid mode. Here we have a comparison to default settings on the drive, and we are just basically running in microgrid mode. Here we can see grid voltages, powers, reactive powers from the grid and from the drive. Okay, let's give about 50% load of active power there. And we can see now that the grid voltage has dropped here and here from the nominal. About 10 volts here, here it's something 13 volts. Okay, always difference between different measurements. And let's put reactive power about 50% there. And we can see now that the line voltage has dropped to 355. So we have to compensate differently the reactive current and active current. Now could be good time to pause the video and go to manual and check from the description AC voltage reference about the capacitor size, inductor size and inductor losses, and also on the commissioning open loop voltage compensation, and come back to the video. And once you have watched the video, come back to again to these parts in the manual. So reactive current 52%. Let's go to AC voltage reference and start to increase inductor size. 3%. What we can see here that our line voltage started to increase, but not enough yet. 6, 12, 20, 22, 24, and now our line voltage here is a little bit over 400, and here in the measurements we can see 400. Let's see how it stays if we increase full reactive power. And now still keeping 400 volts. Some of you maybe noticed that we actually made a mistake here. That's because in the microgrid mode we have voltage drop. But now we are actually compensating this voltage drop away. Thus, the drive cannot operate parallel with the other power sources because regardless of the reactive power, it tries to keep 400 volts on the grid. So no drooping. Let's put voltage drop to 0 and see what happens to voltage. So now it is 420 on the grid. So we have to go back here and start to decrease the value. 20, 19, 18, 18 and a half. Yeah, quite good. Here now it's very easy to see that we need really enough DC voltage, because the supply voltage here in the drive terminals is 471, while our grid is stable 400 volts. Let's drop reactive power to 0 and 100% active power. We can see that our voltage is quite good here. Regardless, when adjusting the active power voltage loss that we will use in inductor losses, and same idea, we increase the value here and it affects the voltage. 15%, and we are a little bit over 400, that's good. Okay, let's ramp it down to 0 kV and see how the voltage behaves. As we can see, the open loop voltage compensation is not perfect, so we have a bit of a voltage drop when the active current is -7%, and we have 394 there, and then it's rising, and it's quite good with the higher powers. This could be that I have some errors in model settings, but let's see what we can do about this. Let's increase our active current to 7%. That's close enough, and we have now lower voltage here. In this point, let's simply increase the voltage reference. So we have a 6 volts, so we put here 7, and now we have about 400. Let's go back to full power. We have now extra voltage, and let's drop this. Now it's 400, and back to 8 kV. $400 seems good. So let's ramp it to 140 and see how the voltage behaves. Now we don't see in the voltage any big drops. 2 volts maybe there, 3. But I would say this is acceptable. Now we have commissioned open loop voltage control. Let's activate the closed loop control. From here, PI activation 02, and we can now see that this voltage correction was affecting here differently. Let's drop it 1 and 0, and now we have 400 volts controlled by drive using the D7. Let's ramp it the power back to 0 and see how now the voltage behaves. And here we can see that the line voltage is just straight line. Let's put here actual 0 in power. And voltage is still straight line.